Before we start a new problem, I want to return to the problem from the previous video, and I'm going to do an encore performance because I would like you to see the whole process of synthetic division carried out in just one box. And I feel like it might even be easier to learn the process without all those red marks all over the place. So here we go. We're going to do the same problem as previous video. We're going to use synthetic division to divide this polynomial by x minus 3. So we write the coefficients of p of x, 1, negative 2, 0. We need to know when to put in 0. 0x cubed minus 11, 0x to the first, and then constant 5. We write a 3 when we're dividing by x minus 3. And here's, I leave a space and draw a line. I bring down the first coefficient. I never do anything but bring down the first coefficient. Then I multiply what I have here times the 3 in front. 1 times 3 is 3. I write that in this next space. Then I add these two entries. Negative 2 plus 3 is 1. I multiply 1 times 3. I write the result here, and I add these two entries. I get 3. Now I take this result times 3 in front. 3 times 3 is 9. Write the result here. Add these two together is negative 2. Multiply negative 2 times 3 is negative 6. Add these together, I get negative 6. Now I multiply negative 6 times 3 is negative 18. Add these two together, I get negative 13. And that last number that I get is always going to be my remainder. And these numbers are coefficients of the quotient. And just remember that this negative 6 is the constant term. And then you want to work backwards when you describe the quotient. Because, see, I don't just look at that 1 and know what power to write down, right? So I start back negative 6 constant, first power, second power, third power, fourth power. So that tells me that the quotient starts with an x to the fourth term. Plus x cubed plus 3x squared minus 2x minus 6. And what we've done is that same problem. I wanted to just pull out one more time. What I also didn't say last time is if you look at the values that we're obtaining, they're really the same numbers that we worked on or obtained along the way of the long division process. We've just streamlined the process to only write down the most essential information to get the result. Okay, so let's start a new problem now. And let's use synthetic division to find p of negative 2 for this polynomial p of x equals x to the fourth plus 2x cubed minus 6x squared plus x plus 3. So p of negative 2 is the remainder on division by x minus a negative 2, which is x plus 2. So there's this strange sign change that we got to be aware of. We want p of negative 2. We're actually going to be dividing by x plus 2. And yet when we set up our synthetic division, the number that I write in front is going to have the same sign as the number inside the function notation is minus 2. So if I'm dividing by x plus 2, I have to write a minus 2 here. If I'm dividing by x minus 2, I have to write a plus 2. So notice these signs will always match. And this one is different. And this, I think you get used to, but it is a little bit confusing the first time you see it. Now, coefficients of p of x, I write 1, 2, -6, 1, 3. I don't think I need any zeros because I got fourth, third, second, first, constant. Okay. Now, let's go ahead and do synthetic division. We bring down the first term. Now we multiply. 1 times -2 is -2. I write it there. I add these two together. I get 0. I take 0 times the -2 out in front. 0 times -2 is 0. I write it there. I add these two together. I get -6. Now I take -6 times -2. Negative times negative is +12. I add these two together. I get 13. I take 13 times -2 is -26. I add 3 to -26. I get -23. And there's my remainder. And so we know by the remainder theorem that p of -2 is equal to -23. Often, that's going to be the only thing we're trying to figure out. Now, we have a quotient here, and there's more information, but not for this problem. All they asked us was find p of -2, so we just pluck off the remainder. Now, I wouldn't, you want to get confident enough that you don't have to check this, but I'm just going to do a check here just so we see for comparison. If I take my polynomial x to the fourth plus 2x cubed minus 6x squared plus x plus 3 and actually plug in -2, I should get the same thing, or I goofed. Of course I got to plug in -2. -2 squared plus -2 plus 3. So -2 to the fourth is going to be a +16. -2 cubed is -8 times the -2 is -16. -2 squared is 4 times -6. See how this is kind of a pain now? 4 is -24 plus -2 plus 3. So these guys cancel out. I have -24, 25, -26 plus a +3 is -23. Just notice these are the same. And here's an example where I think it was easier to do the synthetic division, and we're going to see that in many situations. So we don't want to rely on the check. We want to rely on this process to help us get the function values.